students, we come once again to the next part of the exercise 6.2. We were taking up the application of increasing decreasing functions. I had told you that there are two ways of doing increasing decreasing function. One is by taking x1 less than x2 and so on, and the other one is you have that format. You take f of x, then you take f dash of x and so on. Then we did it with the table. So that's what was going on. We proceed with that. We are now moving to the question number 6. Actually, till question number 5 we were able to complete. Now let's take the question number 6. Question number 6 has got so many subparts. So let's see how we are able to cover. We'll take it like that. They are all more or less polynomial functions, and we had seen that in most polynomial cases, except for one or two, where there is a repeated root. In such cases only there will be a problem, but otherwise when the roots are distinct, you will see that the increasing and decreasing function, they actually alternate in the intervals. So that we'll be observing even now as we solve the problems. So let's get up right away. Question number 6. Find the intervals in which the following functions are strictly increasing or decreasing. Let's take the first one, x squared plus 2x minus 5. That's very easy. Why? Because it's quadratic. Quadratics are generally very easy. Why? Because the root will be only 1, no? So it's easy. The intervals are less. Work is also less. X squared plus 2x minus 5. This is our question number 6. Sub question A. F of x, they don't tell, but we are telling. X squared plus 2x minus 5. They have not told us f of x or something like that, but we are calling it as f of x. F of x is x squared plus 2x plus 5. We all know that we have to take f dash x, and then we have to, if they have told something about the interval, fine, but if they don't tell about the interval, then we have to decide the interval. Then in that case, we should talk about the critical point and get the critical point 0 and so on. All that is going to be our work. So let's do it. Our next step is f dash x. So that is derivative of x squared 2x, derivative of 2x, 2 into derivative of x. A derivative of x is 1, so it is 2x plus 2. Now because we don't know the interval, so to find the critical points, let's have the critical point. So for that we'll make let f dash x be equal to 0, which is 2x plus 2 equal to 0. You can take a 2 common, or you can, let's both same, minus 2, x becomes, that 2 can go there, it gets divided and becomes minus 1. Yeah. So now what we do is, because the critical point is minus 1, we all, like how we have seen in the yesterday's, in the previous class, that this is a real number line and then the critical point is minus 1. So we have these two intervals, one over here and one over here, and that's how we work. So we take a table with say 3 columns. We say the interval, then we say the sign of f dash, and then we call about the nature. So all that let's take up. We'll take two intervals only, sign of f dash. Okay, so the first interval is minus infinity to minus 1. We should look at f dash at any one point there. Now because it's minus 1, what you could take? Minus 2 you could take, or minus 10 you could take, whatever. Minus 2 for example. If you could take minus 2, then what would happen here? 2 into minus 2 plus 2. So that is minus 4 plus 2, negative answer. So therefore what happens is it becomes decreasing in that interval. So decrease. So also minus 1 to infinity. Let's take 0 is there in this interval. So you can take 0. So 0, and therefore what will happen? you find out the interval where it is increasing and decreasing. So right away we can go with the second subpart also. Let's see what the second subpart. It is 10 minus 6x minus 2x squared. They have not told us a function, but then let's take it as so. As usual, we'll take the derivative. No derivative. 6x is minus 6. 2x squared means 2, and derivative of x squared is 2x. So 4x. So to find the critical points, minus 6 minus 4x equal to 0. So how does that go? Minus 4x equal to 6 if you want. So x can become 6 by minus 4, which is minus 3 by 2. Isn't it? When we reduce. So then it's like the case before, you have only these two intervals where you have to work. You have the real number line, and then you have, we won't write it like this, doesn't look so good. You know the real number line. So there is minus 3 by 2. So you have this same thing to be done here. Table with 3 columns. Intervals. Sign of f dash and nature of f of x. So the interval that we would take, minus infinity minus 3 by 2. So a point there. Minus 3 by 2 is minus 1.5. So like before, you could have taken minus 2 or something like that. Should be okay. So let's try f at minus 2. Should be okay. So f at minus 2 means it will be minus 6 minus 4 into minus 2, which means it's minus 6 plus 8 actually. So that's positive. So here it is increasing. So also we go to the next interval. The next interval is between obviously the next interval is between minus 3 by 2 and infinity. And there it is going to be f dash at minus 0. 0 will be there. Yeah, comes to our rescue. So minus 6 minus 4 into 0, which is minus 6, which is less than 0. So that's decreasing. That's about it. So how we look at the intervals and decide whether it is increasing or decreasing. Both are simple problems because we had only one critical point. So that's about this. With more problems, we meet in the next one.